Question A. Find the interval where the function fx equal to 2x cubed plus 3x squared minus 36x plus 4 is increasing and the interval where it is decreasing. First, we need to find the first derivative for the function. The function is 2x cubed plus 3x squared minus 36x plus 4. We use the standard differentiation to get the first derivative, and we will get 6x squared plus 6x minus 36. Then we need to find the critical point where we use the first derivative equal to 0. So the function will be 6x squared plus 6x minus 36 equal to 0. We divide the whole equation to 6 and we will get x squared plus x minus 6 equal to 0. Then we calculate and we will get x equal to negative 3 and x equal to 2. After we get the critical point, we will use it to make the interval. The first interval is negative infinity to negative 3. The second interval is negative 3 to 2. And the third interval is 2 to infinity. Then we use the first derivative test to determine whether the interval is increasing or decreasing. For interval first, we need to choose any number between the range negative infinity to negative 3. So we let x equal to negative 4. We substitute the negative 4 into the first derivative function and we will get 36, which is positive. This means that for interval first, the interval is increasing because the number is positive. For second interval, we let x equal to 0 because 0 is in the range from negative 3 to 2. We substitute into the first derivative and we will get negative 36, which is negative. So it means in the second interval, the interval is decreasing because the unit is negative. And for the third interval, we let x equal to 3. We substitute the 3 into the first derivative of the function and we get 36, which is positive. So this means that the function is increasing on interval negative infinity to negative 3 and 2 to infinity, while decreasing on the interval negative 3 to 2.
Hi, my name is BEEQK1013 and my metric number is 307630 and I will be explain how to solve the question B. So for the question B, we need to search for the marginal profit function. So the profit function is RQ minus CQ, where the RQ is the total revenue and CQ is the total cost. So we need to express RQ in terms of Q, where the price demand equation is P equals to 200 minus 0.98Q, and the total revenue is RQ equals to P times Q equals to 200 minus 0.98Q equals to 200Q minus 0.98Q the power of 2. And then we need to write the profit function using the profit function and substitute the total revenue and total cost. So we will simplify and we will get the profit function is equals to 198Q minus Q the power of 2 minus 800. So for the last step is we need to find the marginal profit function using the derivative profit with respect to Q. So the MPQ equals to D over DQ bracket 198Q minus Q the power of 2 minus 800, and we will differentiate and we will get the marginal profit function is MPQ equals to 198 minus 2Q. So next, for the question Roman 2, we need to find the interval where the marginal profit is falling or rising. So we will simplify and we will get minus 2. The slope of the marginal profit is constant and equal to minus 2, which means MPQ decrease uniformly for all Q. Since MPQ decrease constantly, it is falling through its entire domain. So the marginal profit is falling and the marginal profit is never rising as the slope of MPQ is always negative.
For the next question, it says, determine the average profit AP function. So to find average profit AP, we need to divide PQ with Q, where P is profit function and Q is units produced. Thus, we can substitute the PQ, which is 198Q minus Q squared minus 8,000 divided by Q. And we will get the answer, which is 198 minus Q minus 8,000 per Q. For question C, they have already given us the function of total cost of producing X units of products. So they have asked us at what level of production will the average cost AC will be a minimum. So the first step is we are going to find average cost, which is CX divided by X. CX is the total cost and X is units of products. So we will divide 0.02x squared plus 2x plus 8,000 with x. And we will get 0.02x plus 2 plus 8,000 per x. In the first step, we have found the average cost function. Next, we have to find the level of production that minimizes the average cost. First, we have to find the first derivative of the average cost function, and we will get 0.02 minus 8,000 per x squared. Next, we need to find the level of production, right? Which is x, what units of x is produced when average cost is minimum. So we have to substitute the first derivative into 0. And 0 equals to 0.02 minus 8,000 per x squared, which is our first derivative. And we will get x equals to 632.46, which is approximately 632 units. It doesn't end there. We have found the function of average cost, the first derivative, and the level of production when average cost is minimum. So to double check or confirm, we have to find the second derivative of the average cost function by differentiating the first derivative of average cost function. So we will get 16,000 per x cubed. And the x is equals to 25, which is x is more than 0. From here, we can confirm that when we differentiate the first derivative and the second derivative, x is more than 0. So we can confirm that here, 632 units is the level of production when average cost is minimum, indicating the function is concave upwards, which is the smiley face graph. And that's all from me. I'm Nazor Shah. Thank you.
Question D. What is the price elasticity of demand when quantity is 10 if a firm demand function is Q equal to 60 minus 2p to the power of 0.5, where p to the power of 0.5 more than equal 0 and Q less than equal 60? First, we need to find the first derivative of the demand function. The demand function is Q equal to 60 minus 2p to the power of 0.5. We use the standard differentiation to get the first derivative, and we will get negative 1 per p to the power of 0.5, or we can also call it square root p. The second step is we need to find p when q equal to 10. So we substitute the demand function q equal to 60 minus 2p to the power of 0.5 and equal it to 10. So we will get 10 equal to 60 minus 2p to the power of 0.5. We will need to calculate the equation until we get p equal to 625. Then, after we get the p when quantity is 10, we will need to calculate the price elasticity of demand, which the formula is dq per dp times p per q. So, the price elasticity of demand, we will need to substitute the amount into the formula. First, dq per dp is the first derivative that we already calculate, which is negative 1 per p to the power of 0.5. But we already calculate that when q equal to 10, the p is 625. So, the amount we will need to put here is negative 1 per 625 to the power of 0.5 and times it with price which is 625 per quantity, which is 10. So the price elasticity of demand is negative 2.5.